DMD250, Intro to Data Visualization. How is everybody? All right, let's take a look at the Week 4 module, and we'll check out the Week 4 overview here. Okay, so lots of good stuff going on this week. The first thing we are going to do is take a look at the forms that data visualizations take. Now, up until now, we've looked at the history of data visualization, and in doing so, we've seen a variety of different types of charts and graphs and whatnot that have sort of appeared over time, been invented by a variety of different people, and of course, some of which you're familiar with anyway, just from sort of day-to-day life. But we're going to take a closer look at these different forms that data visualizations take, because coming up next, you guys are going to start making your own data visualizations. And so, of course, before you can make them, you got to be familiar with them. So everything from diagrams to maps to tables to charts and so on, each one has sort of a purpose and a way of working with them, and they're good at some stuff and maybe not so good at other stuff. So you got to be able to choose the appropriate form of data visualization when you are creating them. Not to mention the fact you can create brand new ones from scratch just by simply using your imagination. And so we're going to get into that as we go along too. Now, the major tool, the major digital tool that we are going to use to create our data visualizations in this class is a tool called Infogram. And so we're going to take a look at our All About Infogram handout, which you can find right here in the overview. You can download this, take a look at it. And then we're going to introduce our Project 1, which is our first data visualization project called Visualize Your Life. So we're going to take a look at that. Meanwhile, in the background, you guys are still working on Project 2, your research and inquiry project. That's going to run for a few weeks. Due at the end of this week, on Friday of this week, is part 1 of Project 2, which is the background research and the writing of your inquiry question. So that is due at the end of this week, so make sure you have that finished and uploaded by the end of the week. And then for homework, we're going to start that new project, Visualize Your Life, and of course you're going to continue along with the research and inquiry project. Okay, so let's start by taking a look at the forms data visualizations take. The handout we're going to go over you can download right here as well, so if you want to follow along or just have it for reference. Okay, so this is excerpted from Data Visualization Types from an article from Duke University by Angela Zos. You can look at the entire article here, but this is sort of an abridged version of it that'll help us understand the different types of data visualizations. Now, of course, the one you're probably most familiar with, which is also the oldest one that has record of being published, is of course the pie chart. It's a circular statistical graph, which of course is divided into slices, which is why it's called a pie chart, because it looks like a pie, like a pizza pie or an apple pie or something like that, to illustrate numerical proportion. In a pie chart, the arc length of each slice, and consequently its central angle and area, is of course proportional to the quantity that it represents. So the bigger the slice, the more stuff numerically that it represents. The smaller the slice, the less stuff numerically that it represents. Now, of course, it's named for its resemblance to a pie. There are variations on the way it can be presented naturally. We've seen some of those going over the history of data visualization. And of course, the earliest known pie chart is credited to William Playfair, who we looked at. He was the first person we looked at in our history of data visualization from 1801, from a publication that he put out in 1801 called Statistical Breviary. So pie charts, of course, are widely used in the business world and mass media, and they have come to be criticized, as many experts recommend avoiding them, pointing out that research has shown that it is difficult to compare the different sections of a given pie chart or to compare data across different pie charts. Now, I'm not sure I agree with that necessarily. I think that they are fairly ubiquitous. There's probably an overuse of them when people have to create data visualizations for work, for a presentation, if you're using Microsoft Excel or some other data-driven program that creates charts. People tend to gravitate towards the pie chart just because it's so familiar. So I think in that way, you could say that it maybe isn't always the best choice, but it's the obvious choice. But I wouldn't discount them entirely. I think they certainly serve a purpose in a lot of different areas. I think for immediate recognition, that is probably one of your best bets. Everybody understands what a pie chart is, meaning you don't have to teach them how to read the chart. It's pretty obvious. So I think in that way it has its benefits. But on the other hand, there are more exciting, visually engaging, and probably accurate charts that you can use. Okay, so another really common one is the bar chart, and of course this also gets credited to Playfair, which we saw in our history. And a bar chart, sometimes referred to as a bar graph, represents categorical data with rectangular bars with heights or lengths that are proportionate to the values. So of course, the longer or the taller the bar, then the more data that's being represented, and the shorter the bar, then the less data that's being represented. They can be plotted vertically or horizontally. So the nice thing about a bar chart is it works in either area. And one thing about a bar chart rather, is that similar to spreadsheets, it works with sort of three areas. So just this example here, you can see that there's numerical data that runs down the vertical axis. There is these alphabetical letters that are running along the horizontal axis at the bottom. And then the different heights of the bars is what triangulates the position between the two. So you could say the blue bar of A is at 10. Now, I have no idea what these numbers represent, or the letters. It doesn't matter. You can just triangulate it, meaning you go over from the 10, down from the blue bar, and you land on A. So you could say 10A or A10, and that's your representation. That's your triangulation right there. Here we have 8A or A8. So it's real easy to figure out like what part of the bar you're looking at. Even if we were to put in little horizontal lines along the bars to show different sections, you could find those really easily too. So it works on the same axis situation that a spreadsheet does. So in that way, it's pretty familiar. And again, this is one of the older representations of charts dating all the way back to Playfair. Now, a Gantt chart is a type of bar chart. So sometimes we find charts and graphs that are derivatives or evolutions of existing ones. The donut chart, for example, is an evolution of the pie chart. The Gantt chart is an evolution of the bar chart. So it illustrates a project schedule named after its inventor, Henry Gantt, who was around from 1861 to 1919. He designed such a chart around sometime between 1910 and 1915. He designed this chart, and really, instead of putting the bars of a bar graph next to each other, he overlaps them to show relationship information. So modern Gantt charts also show the dependency relationship between the activities and the current schedule status. And so these tend to be used when tracking time, sort of information over time. So again, we have a vertical axis that shows numerical information. We have a horizontal axis that in this case is showing dates, January 1st, January 8th, January 15th, and so on. And you can see that the information, whatever this might be, spreads over time in a linear, almost timeline fashion, which if you're familiar with animation or motion graphics, you sort of understand that that works horizontally from left to right as well. Okay, next we've got scatter plots or connected scatter plots. So a scatter plot, also called a scatter plot, all one word, or a scatter graph, or a scatter chart, scattergram, it's got a whole bunch of different names that are attributed to it. It's a type of plot or mathematical diagram that uses coordinates to display the values for typically two variables of a set of data. If the points are color-coded, one additional variable can be displayed. So obviously the different colored dots represent different types of data. And of course you can connect those dots just like you would do a connect the dot game or a drawing that sort of shows a line that can be followed along the dot. So here on the left we have the regular old scatter plot that again shows a vertical axis and a horizontal axis of whatever these numbers represent. And you can sort of see where the dots fall. So if I were to look at this uppermost red dot, I can say that it's somewhere between 12 and 14, not quite halfway, so it's maybe not 13, it might be 12.75 if I had to guess. And then down here you can see that it falls a little bit after the 12, but again, not quite 13, so that could also be 12.75. So maybe that is the coordinates for this, 12.75 by 12.75. Now, it would be helpful if this chart had some vertical lines that helped us line up the vertical numerical values, but obviously these can be altered. Just because these samples I'm showing you are good representations doesn't mean it's the only way to do it, right? You can do everything from choose the colors to change the typography to add additional framing mechanisms and graphics that help people better understand it. So you're not really locked into this look. You can make some adjustments. And then over here on the right we have the connected scatter plot, which is really the same thing except that you're drawing a line between the dots that sort of show a trajectory of the dots. In fact, you can see the end of this line is an arrow, so it very much is a path that you are meant to follow. Okay, next we have the polar area, or the rose diagram. Now, the polar area diagram is similar to a pie chart, except that the sectors have equal angles and differ rather in how far each sector extends from the center of the circle. So you have the pie slices, like in a pie chart, so that we understand. You can see the different widths. But then it also has these lengths extending out from the center of the circle. So it's almost like a pie chart and a bar graph sort of got together and had a new chart together, in that it shows you the width of the slice, but also the height of each one, or the depth of each one. Now, the rose diagram is similar to this in that it uses those same two conventions, the slices and the lengths, but it's usually not as structured as this. Like a lot of these grid structures would be invisible, or you wouldn't see them. You would only see the colored sections that represent the data. So it sort of works out, nicely that way. Now, the version that does not have all the built-in structure is the rose diagram, which was developed by Florence Nightingale, which of course we covered in our history of data visualization. And so it's gone on to become this polar area chart, but they're extremely similar to each other. They accomplish the same thing, and they look kind of similar. Okay, next we have the alluvial diagram. So it's a type of flow diagram, and oftentimes I will show diagrams like this, and I will just call them flow charts, because there's a number of different types of flow charts or flow diagrams that sort of look like the waves in the ocean, right? They're flowing along smoothly, they're curved lines, they're very kind of, they undulate up and down, so it looks like a flow, right? And so I'll usually refer to those kind of generically as a flow diagram or a flow chart. But really there's different types. So this is one type, the alluvial diagram. And it was originally developed to represent changes in network structure over time. And a network, of course, could be a team of people, or it could be a literal network of data. A network is an interlocking collection of information, people, places, things, whatever. In allusion to both their visual appearance and their emphasis on flow, alluvial diagrams are named after alluvial fans that, of course, are naturally formed in the soil deposited from streaming water. If you see the way soil forms itself along sort of a rushing stream or a babbling brook or whatever, it looks like these kind of really layered, curved, wavy kind of shapes. And so those are called alluvial fans, and so that's what this is named after. Now, even though this is what this particular diagram was designed for, it doesn't mean you can't repurpose it for other things. Notice in this one we have still a vertical axis. Over here it's different types of medicine, right? We have neuropathy, psychology, neurology, psychiatry, oncology. So these are different areas of focus or specialty in the world of medicine. And then along the bottom here we have years, the year 2001, 2003, and whatnot. And you can see that there's a relationship between the types of areas of medicine listed on the left-hand vertical axis and the right-hand vertical axis. These things are related to each other based on how the flow goes, as it were. So that's another really cool, interesting diagram. Okay, next we have arc diagrams. It's a style of graph drawing in which vertices of a graph are placed along a line in this plane running along the bottom with edges being drawn as semicircles. So it basically looks like half circles all the way through. And what the half circles do is they show you the relationship between the items that are listed along the bottom. So there's a whole bunch of different items listed along the bottom horizontally, but the typographic representation of them is vertical, so you have to sort of turn your head to read them. But you can see, because it's an arc, you can see a starting point, so like where it starts, and then you follow the arc all the way up and over, and then it lands on another item in the list. So it shows relationships between the two. And of course, the size of the arc is dependent on the distance between the two items in the list. The further away they are from each other on the list, the larger the arc's going to be. The closer they are, the smaller the arc is, because these are all based on circular arcs. So you can't adjust the length using ovals. It's all circular, right? The use of the phrase arc diagram for this kind of drawing follows the use of a similar type of diagram which was invented by Wattenberg in 2002 to visualize the repetition patterns in strings by using arcs to connect pairs of equal substrings. However, this style of graph drawing is actually much older than the name that was given to it. It's much older than 2002, and it actually dates all the way back to 1964 and 1968 with these two people, Satay and Nicholson, who used a type of arc diagram to study crossing numbers of graphs. An older but less frequently used name for the arc diagram are linear embeddings, which is a sexier sounding name, but maybe not quite as visually accurate. This is made up of a whole bunch of arcs, so why not call it an arc diagram? Works out nicely. Okay, next, my favorite type of chart or graph is the bubble chart or the bubble cloud. I love these. A bubble chart is a type of chart that displays 3 dimensions of data. Each entity with its triplet of associated data is plotted as a disk or a circle that expresses 2 of the v values through the disk's xy location. Now, of course, let's talk about x and y, right? So if we're talking about axes or axi, the x-axis is horizontal, the y-axis is vertical. This comes up a lot in visual design classes because we're talking about space, right? And here we're dealing with 2-dimensional space, so the x-axis runs from left to right, the y-axis runs from top to bottom. If we were dealing with a 3rd dimension, 3-dimensional space, we would have a z-axis, which runs from furthest point away to closest point away. Now, bubble charts can be considered a variation of the scatter plot. They do sort of look like scatter plots. However, here, whereas in scatter plots, the circles are all exactly the same size, here the circles are not only placed on the graph for location, but each circle has a different diameter. They're bigger or smaller, which indicates quantity of the item that's being shown inside the chart. So it really covers 3 different ways to do it. So you can use a bubble chart instead of a scatter chart if your data has 3 areas that need to be measured, right? The size of the bubbles are determined by the values of that 3rd set. So for example, if we look at this circle in the upper left corner here on this particular chart, you can see that the center of that circle is squarely at 50, whatever 50 represents, doesn't matter. And then you can see the center of it vertically on the y-axis is squarely on sample 1. And of course, the bubble cloud is similar in that it maintains the whole premise that the larger the circle, the larger the quantity that's being represented, the smaller the circle, the smaller the quantity that's being represented. That's all easy to understand. But instead of using a framework like this chart over here behind the bubbles, here they're just floating around in sort of an amorphic cloud. And it really relies heavily on color coding. So without even reading the words that are inside the bubbles, you can kind of get an idea right off the bat which colors there are more of something, which colors there are less of something. So if we look at green, with the exception of this green bubble out here on the far left, all the other green bubbles are relatively small and almost tiny. So from a quantity perspective, at least on each individual bubble, there's not a lot of them. Now, if we added them all up, maybe it would be more than the other colors. But either way, you can make a quick visual assessment by looking at the colors, the size of the bubbles, and then you can take a deeper dive by reading the typography that's on each bubble and sort of determine what's going on. Okay, so that's a bubble chart and a bubble cloud. Then we have a ring or sunburst chart. Now, this kind of looks a little bit like the rose diagram, and it does have a lot of similar features to it. So a ring chart, which is also known as a sunburst chart, which, by the way, I would stick with the sunburst chart name. I think that's a much nicer name. It's a multi-level pie chart. So like the rose diagram, it does use some elements from the pie chart in terms of sort of wedge slices. Now, if this was only one level, if it was just this inner circle with the different wedges and a hole cut out of it, I would refer to that as a donut chart. But then you start adding these outer rings, these outer layers, and then it really becomes sort of a sunburst chart. The circle in the center represents the root, meaning the 0 point, or the root node, so right in the middle would be 0. With the hierarchy moving outward from the center, so meaning as we get further away from the center, the numbers go upwards. Now, there's no numbers attached to this or anything, but just visually, you can look at it and sort of make some assumptions based on the pie chart wedge sizes, the amount of data that extends outwards from the center, and so on and so forth. There's a hierarchical relationship between all of these segments of the outer circle, which lie within an angular sweep of the major segments. So the major segments are on the inside circle, gray, light purple, medium purple, dark purple, and then so on and so forth. And then all of the ones that extend out from that get their color coding cues from those inner circles, and then the data extends outwards. The sunburst chart is probably one of the most visually attractive looking charts for sure. Okay, and then lastly we have maps. Now, of course, maps we talked about as sort of almost like secret data visualizations. We generally think of maps as their own category, but really maps are just data visualizations. Now, of course, there's a wide variety of types of maps. Here we have an example of one that's sort of geographically realistic, meaning it's trying to be as accurate as possible to the geography that it's depicting, this being North America, of course. And of course, the color sections and whatnot, they're showing some areas of data that are demonstrated over here in the key, which are color-coded. But they're trying to be as realistic as possible. Meanwhile, this one here is a different kind of map that is talking about media players, maps, mail, etc., etc. But this is not geographically accurate in any way. In fact, you've probably seen maps that look similar to this for transit systems. If you've ever been on public transportation in major cities, New York, Boston, whatever, you can see that the train maps tend to look like this, and they show the various stops along the way that the train takes. And while it has some relationship to north, south, east, and west, they don't try to be geographically accurate. They're just trying for you to understand the train routes as simply as possible. Now, of course, there's other charts, graphs, and visualizations that are not shown here that we actually did see in some of our earlier examples, like the Venn diagram. But you can go to the main article this comes from right here if you really want to get into a much deeper dive. But I just wanted to go over some of the larger ones. In fact, there's a couple shown here on the cover page, this one here, this one here, this one here, which are not covered in this handout either. So there's way more data visualizations to get into. This is just the tip of the iceberg. So I want you to do your research, treat this like textbook reading, and really sort of get into it and go over what's going on. Okay, just so you're familiar with them, because we're going to start making them. Okay, next on the agenda, speaking of making them, we're going to talk about the main digital tool we're going to use to make our data visualizations. We're going to use a program called Infogram. Now, Infogram is a free digital tool that is available on the web through a web browser. And so the handout you can get from our week to week is this right here, the All About Infogram handout. So what you need to do this week is set yourself up with an Infogram account. So Infogram is an intuitive data visualization tool that helps you create beautiful data-driven interactive content, which is what we're going to do in this class. So there's the link to Infogram, and let's just hop out there and take a quick look at it. And then we'll go over what you're going to do this week. Just set aside a little bit of time to get yourself set up on Infogram, because we are going to be using it for all of our data visualization projects starting immediately. So you want to get set up and become familiar with it. Okay, so let's take a look as it loads here. Okay, so this is their main website, and you can see about a little animation that's happening. Gives you an idea of how Infogram works. So signing up is real easy. If you go to log in, it gives you the option to log in either by creating a brand new account with your email address and make up a password, or you can log in with one of these methods here, either with Facebook, which I don't normally recommend because Facebook does not do a good job of keeping your data private. I would leave that alone. You could log in with your LinkedIn account. You could log in with Twitter, which I maybe might not recommend either, or you could log in with Google, which is generally fine. So this is what you're going to do this week is your initial setup. You're going to go to login like I just showed you. I suggest logging in with Google, but it's entirely up to you how you log in. Just make yourself an account. So by logging in with Google or one of the other methods, this will give you access to their free basic account, which is all we need for this class. There is a paid version of Infogram that gives you more features, but we don't need all those for this class. We're going with the free basic one, okay? Then in the upper right corner, once you've logged in, click on the profile icon and then choose account settings. And then from there, you're going to fill out your basic information, and you can even upload a profile image of yourself if you would like. You don't have to, but fill out your basic information. Now, I need that basic information filled in because when you are sharing your data visualization projects with us, this way I will know it's from you. So it works out pretty good, right? Now, the other thing you're going to do this week is you're going to kind of get to know the basics of Infogram. You're going to play around with it and learn how to use the software basically. We're going to cover some of it in class, but I really want you to sort of spend some time on your own, toying around with it and getting to know it. So to do that, you would be best served by getting a head start on the class by watching these two videos. So there's this one here, Getting Started with Infogram, which is a great YouTube video which kind of goes over all the basics. So you can check this out. And this is directly from the folks at Infogram. So they cover a lot of the basics really nicely. So that's the first video. And then this here is Infogram's YouTube page. If you want to dive deeper past the Getting Started video, this will take you to a whole bunch of tutorial videos that Infogram has on their YouTube page, all of which are put together really nicely. They're very brief, but as you can see, there's a bunch of them. You specifically want the how-to tutorials. You can see that there's a whole bunch of them you can go through. There's about a dozen or so. And they're all short. They're all a couple of minutes each, so it won't take you long to get through the basics. Then you can move down to tips and tricks if you want to learn a little bit more, and basically go as deep into it as you would like. At minimum, cover the basic how-to tutorials. And of course, this Getting Started one, okay? Now again, we only need the free basic account. However, if you really fall in love with Infogram after you have done the Learning the Basics section here, and you're like, I love this software, and you want to explore some of the expanded functionality, then you can sign up for a pro level account for $25 a month. You could literally pay for it for just 1 month and play around with it if you would like. But again, for this class, it's entirely optional. The free version of Infogram is all we really need. And here's some examples of the types of data visualizations you can make in Infogram. So we're going to really get into this soon. Okay, so that's homework number 1 for the week. Homework number 2 is we're going to get started on our first project, which is called Visualize Your Life. I should say our first data visualization project. We have our inquiry and research project already underway. So the first thing you're going to do here is, using either Google Sheets or Microsoft Excel, you're going to create a really basic to mid-level spreadsheet that tracks something in your life. Now, we're going to go over in class how to do that, but I'm just going to read through this now, and then the main thing you're going to do starting now for homework is decide what it is you're going to track. Now, this could be your collection of Hot Wheels cars, the number of times you have visited a certain place for different occasions. It could be an inventory of holiday decorations in your garage, your music listening, video games you've played, the number of miles you walk in a given week, whatever it is you want to track. How many vegetables you eat, I don't care. You come up with what you want to track. So between now and the next time we meet this week, you want to decide on what it is you're going to track. So that's really your only homework for this project, to decide what am I tracking, and maybe start collecting the information or figure out how you're going to collect the information. Now, how to make a basic spreadsheet in either Google Sheets or Excel, we're going to go over together in class, but you are free to obviously start working ahead here. And then the next thing we'll do is, of course, dive into Infogram to go ahead and make our data visualization. You can read through here, and we'll cover all this in class together. But get started on thinking about and deciding upon what it is you want to track. That's really important. So make sure you come to class this week knowing what it is you want to track. Okay, so that's it for this week. Other than that, of course, make sure by the end of this week you turn in your background research and inquiry question, which is part 1 of project 2. So lots to do this week. It's a busy, busy week. Get to know Infogram, understand the different types of data visualizations, and get rolling on project 1, Visualize Your Life, by deciding what it is you would like to visualize. All right, so that's it for now. I will see you guys soon. If you need me, you know where to get me. Monday and Friday office hours. Email, the usual. I will see you soon.